Good morning, all of you. Today we'll be discussing if angular displacement is a vector or not. So, for a physical quantity to be a vector, it must have magnitude, it must have direction, and also it must be commutative in vector addition. We have learned that the angular displacement has magnitude, it also has direction. Now we need to test if it is commutative in vector addition. So if theta 1 and theta 2 are two rotation transformations of this body, if angular displacement is a vector, then theta 1 plus theta 2 must be equal to theta 2 plus theta 1 to obey the commutative law of vector addition. Now if we consider this as x-axis, this as y-axis, theta 1 is rotation about x-axis by 90 degrees in counterclockwise sense, and theta 2 is rotation about y-axis by 90 degrees in counterclockwise sense. So first we will apply the transformation theta 1 plus theta 2 to this body. So first it is rotating 90 degrees about x-axis, next 90 about y-axis. I will play it once again, have a look. Next we will perform this transformation theta 2 plus theta 1 on this body, which means first rotation about y-axis by 90 degrees in counterclockwise sense, and then rotation about x-axis in 90 degrees by counterclockwise sense. I have put these clocks here so that there is no confusion that we are doing clockwise rotation or anti-clockwise rotation, right? See, about x-axis, if you are doing anti-clockwise, you can see that object has to rotate in this direction. So to make it simple for you, I have put these clocks here and here. Let us now apply the second transformation theta 2 plus theta 1. So first rotation about y-axis and then rotation about x-axis. Let me play it again. Now observe the orientation of the body after you have performed the transformations theta 1 plus theta 2 and theta 2 plus theta 1. After doing the transformation theta 1 plus theta 2, the body is like this. After performing the transformation theta 2 plus theta 1, the body is like this. So we can conclude that theta 1 plus theta 2 is not equal to theta 2 plus theta 1, which means angular displacement is not obeying the commutative law of vector addition, and so we can say that angular displacement is not a vector. Now let us again apply the rotation transformations, but now the magnitude of rotation is 45 degrees. So first here we will do the transformation theta 1 plus theta 2, then theta 2 plus theta 1. So let us do the transformation theta 1 plus theta 2. So first about x-axis by 45 degrees counterclockwise, then about y-axis by 45 degrees counterclockwise. So this is the final orientation of the body. Let us now perform the transformation theta 2 plus theta 1. So first rotation about y-axis by 45, then rotation about x-axis by 45. So now again the orientations of the bodies are different in these both cases. So theta 1 plus theta 2 is not equal to theta 2 plus theta 1. So again commutative law is not satisfied. So angular displacement is not a vector. Now we will again apply the same transformations theta 1 and theta 2, but the magnitude is not 45, it will be 15 degrees now. Let us first apply the transformation theta 1 plus theta 2. So first 15 degrees about x-axis and then 15 degrees about y-axis. Let us move on to the second one, theta 2 plus theta 1. So first 15 degrees about y and then 15 degrees about x. Observe the orientation of these two bodies. They are still not similar. The angle we have turned through is 15 degrees. Let us again do the rotation transformations. Now the angle rotated is 5 degrees. Firstly, let us perform the transformation theta 1 plus theta 2. So first rotation about x-axis by 5 degrees and then about y-axis by 5 degrees. Now let us do the transformation theta 2 plus theta 1. So first 5 degrees about y-axis and then 5 degrees about x-axis. Could you observe and see when we did the transformation theta 1 plus theta 2, the body was like this. Theta 2 plus theta 1, finally the body was like this. And we can see that the orientation of this body is almost similar to this body. So as we gradually decreased the amount of rotation, theta 1 plus theta 2 was becoming equal to theta 2 plus theta 1. Summarizing all the transformations that we have done till now. So first the transformation that we had done is 90 degrees. So the final orientation of the object after doing the transformation theta 1 plus theta 2 was like this. And after doing theta 2 plus theta 1 was different from this. So we said that it is not a vector. So angular displacement is not a vector. Next, we did the transformations for 45 degrees and this was the initial orientation of the body. This was the final orientation of the body. So again theta 1 plus theta 2 is not equal to theta 2 plus theta 1. Angular displacement not a vector. Next we applied the transformation for 15 degrees and this is the initial orientation of the body and this is the final orientation of the body. And we are seeing that slowly the theta 1 plus theta 2 and theta 2 plus theta 1 are a little more similar than what they were very initially. The last transformation that we had done is for 5 degrees and we see that the orientation after theta 1 plus theta 2 is almost similar to the orientation after theta 2 plus theta 1. So we make a very important conclusion here that finite angular displacement is not a vector, but as this angular displacement, the value starts decreasing, it behaves like a vector because it obeys the commutative law of vector addition. So we can conclude that very small angular displacement is a vector.